3.5 graphs of functions. How do you know if it's an even function, an odd function, or a neither function? So an even function is symmetrical to the y-axis. It's like a mirror. You can fold it in half. It's symmetrical to the y-axis. And another way you can tell, I like doing it this way instead. If x is 2, the y needs to end up being a positive 4, and then if x is a negative 2, the y is also the same answer. So you could put in two opposite x values, and if the y values come out to be the same, then it's an even function. An odd function, like this one, like a snake, is, again, it's symmetrical to the origin, but I like testing it using points. I like using like x and a negative at x equals 2 and a negative 2. If one is 4 and the other one comes out to be the opposite of it, then it's an odd function. And a neither function is, for example, if you tested like a 1 and a negative 1, you don't always have to stick with 2 and negative 2. You can do 1 and negative 1. And if one y value is 7 and the other y value is such a random number like 3, it's neither function. So check an positive and a negative same numbers, positive and negative same numbers, positive and negative same numbers. If they turn out to be the same, it's even. If they turn out to be opposites, it's odd. And they turn out to be completely different, it's a neither function. So just remember that. So for the first part of the assignment in part 1, let's see if you guys remember what I just said on that first page. This is a chart, and the first chart is your x and your f of x, and this book does it horizontally, but you can look at it like this if you want to vertically, but this book does it horizontally. So it goes a negative 3 and 3, and under the 3 there's a negative 5. And suppose f of x is an even function. What does it mean to be even? Let's go back. To be an even function, the x values are opposite of each other, but the y values have to be the same. So to fill in the chart, which you'll have to do on the test, for it to be an even function, this number also needs to be a negative 5 to be an even function. G of x is an odd function. So you're going to disregard this one. Your x is still a negative 3 and a positive 3, but your y values are now 15. To be an odd function, this number needs to be a negative 15. So do you see how you do that? Okay, the next one. Tell me if it's an odd, an even, or a neither function. Tell me if it's an odd, an even, or a neither function. So what I'm going to do is do what I was just doing on the first part. Y has to be 8 for this one. Y can only be 8. X can be anything it wants to be. So I want my x's to be a 3 and a negative 3 because they have to be opposite. But the y has to equal 8. Well, the x's are opposite, but the y's are the same. It's an even function. Okay, let's do another one. Y equals x to the third minus 1 over x. I'm going to do an x and a y chart. And I'm just going to pick two numbers, like, I'm just going to use 2 and negative 2. When you put 2 back up in there, you get 2 to the third minus 1/2. 8 minus 1/2 is 7.5. If I put a negative 2 in there, a negative 2 times a negative 2 times a negative 2, which is a negative 2 to the third minus 1 over a negative 2, which makes a negative 8 plus 1/2, which makes a negative 7.5. Again, I pick two opposites for x. My y values come out to be opposites. it's an odd function. And the last one, x and y. I'm going to use 4 and -4 on this one. Let's see, 4, this is kind of big. 16, 3 parentheses, 4 squared minus 5 times 4 plus 1, and 3 parentheses, a -4 squared, minus 5 minus 4 plus 1. We are going to get 48 minus 20 plus 1. 48 minus 20 is 28 plus 1 is 29. This is going to give us a positive 48 plus 20 plus 1, 68, 69. These numbers are not even close to being the same. They're not the same and they're not opposite. It's not an odd, it's a neither function. Because it's not the same and they're not opposite. I think you get the idea about that now. Okay, part 3, translations of graphs. It's been a while since you've done translations of graphs. So, this is the formula down here. This is how you translate a graph. If there's a number inside of here, it moves side to side. It moves side to side. The number on the outside moves it up or down. The negative sign flips the graph. If the A is less than 1, it makes it wider. And if A is greater than 1, it makes it skinnier. So, for this part, you're supposed to be able to translate these graphs. And we did this in Algebra 2 last year. All you're going to do is make yourself an XY chart. I'll wait for you guys to maybe do that. Okay, this is a squared, and a squared makes a parent graph of a parabola, if you guys remember your parent graphs from last year. Look to see where the -2 is located. It's located inside of a grouping symbol, so it's going to move it side to side. A -2 moves it to the right 2. The 3 is outside, it moves it up 3. And then you make yourself your parabola. This is a very fast way of graphing using translations. Okay, the next one, if you remember from Algebra 2, is an absolute value graph, and an absolute value graph makes a V. But you're going to do some things with the V. So first of all, you're going to move it to the right 2 because that's inside, so you move it to the right 2, and you're also going to move it up 4. So that's your new vertex. To the right 2 and up 4. Negative goes to the right, positive goes to the left, if you guys remember that from last year. The negative sign is going to flip the graph, so it's going to be an upside down V. And the number, not the negative sign, get rid of the negative sign, just the 2 is greater than 1, so it's going to make it skinnier. So you have to flip it and make it skinnier than the original graph. I flipped it and I made it skinnier than the original graph. And the last one, last year you learned what a square root graph looks like. It looks like this. It looks like a swoosh. You're going to move it to the left 1 because the plus 1 is inside of there, so I'm going to move it left 1 and down 4. There's my new square root. I went to the left 1 and down 4, and then you're supposed to make it a little bit wider, but it's kind of hard to make that wider because 1/3 is less than 1. So you make it wider. Okay, I think we're on the last part. I'm not gonna teach 7 and 8. It's not on the test, so I'm not gonna even go there. With COVID, why teach you some extra stuff? So I'm just gonna stop at 5 and 6. How do you make piecewise graphs? And we did this in Algebra 2 last year, but this is found in calculus throughout the whole book. So this is very time consuming, so we're gonna do 2 of these. I think a lot of you remember making these XY charts, and you need 3 divisions. It's called a piecewise graph because you're only having a piece of this one, you're gonna have a piece of this one, and you're gonna have a piece of this one. This is really important because this tells you where you should start your x, and I'm gonna start my x at a -2, but I want 3 points for each section, and I want it to go in numerical order, so in numerical order would have to be a -3 and a -4. So it goes in increasing order. And then what you want to do is you want to plug a -2 up in here, and you're going to get a -1. Put a -3 up in here, you're going to get a -2, and this one's going to make a -3. Okay, the next one, x is less than 1, x is less than 1, and x is greater than a -1, if you remember absolute value from the last chapter. You need to be between 1 and a -1. So a -1 is going to go here, and a +1 is going to go here. Remember, your x values need to go in increasing order. So I know the -1 goes there, and a +1 goes there, and I want 3 points. So I'm going to put 0 in the middle, and I'm going to put a -1 into this equation. This equation right here, and I'm going to get a +1. I'm going to plug 0 in and get 0, and I'm going to put a 1 up there and get 1. Okay, my last one, it says that I have to start with 3, so I need to put a 3 here, but I want 2 more points, and I have to go in numerical order. And then I'm going to put a 3 in here, and I get a -3 and a -4 and a -5. So that's what my chart looks like if you remember this. If you look over at the board, this title is called Piecewise Graphs. If you look over in Algebra 2, they are learning how to do piecewise graphs this week. So now what we have to do is graph these. So how do we graph these? Okay, how do we graph these? If you remember, there's a line underneath here at -2, so this one needs to be a closed circle. There is no line right here for the 1 and the -1, so those are going to be open circles. And the 3 has a line underneath it, so that's a closed circle. So specifically at these lines right here, on either side of those, I have specific open and closed circles. Once those are completely done, the rest of them are always closed circles. If you remember this from last year. So this little code right here will let you know if you should put an open circle or a closed circle at that spot. So at a -4, -3, which is right here, at a -4, -3, it's a closed circle because it says to use a closed circle. At a -3, -2, it's another closed circle. At a -2, -1, it's another closed circle. And I want that everything less than a -2. Everything less than a -2, that means I could have made more points to the left, but I only did 3 points. At a -1, 1, it's an open circle. Everybody see why? At 0, 0, it's a closed circle. And at 1, 1, it's an open circle, and you connect your points, and there's no arrow for the middle one because it's bounded between a -1 and a +1. At 3, -3, it's a closed circle. At 4, -4, it's a closed circle, and at 5, -5, it's a closed circle. And I could have did 6, and I could have did 7, which would be out here somewhere, so that's why that arrow's going off in that direction. You're doing a piece of a graph. You get 1 point if you can get this one right. You get 1 point if you get this one right, and you get 1 point on the test if you can make that one right. So let's do one more on how to make a piecewise function. Let's pretend that that's not there. If you only have 2, then you'd only need 2 sections, but we need 3 for this one, so that's why I'm going to make a 3 section. But sometimes in calculus, you might have 5 sections, so you'd have to divide your chart up into 5 sections. So just giving you a heads up, in college algebra, depending on how many pieces that they want you to break it up into. Okay, so this one's 3 again, so I need 3 sections. This lets you know where to start. This line right here tells you that the number on top of it needs to be a -2. And we have to go in numerical order, so these numbers need to be less than a -2. In the middle, I need to go from a -2 to a +2, from a -2 to a +2, and I only need another number in between. I can use a 1. I'm just going to use a 1. I could have used 0. I could have used whatever I wanted to. And in this one, I'm going to start the next one at 2 and go 3 and 4. As long as these numbers right here are in increasing orders, which they are. Okay, now I got to figure out if it should be open or closed circles. Okay, so let's look at -2, which is this one right here. And it needs to be a closed circle because there's a line underneath it. Here's the other -2, and look at that. There's not a line underneath it, so that's an open circle, but this one has a line underneath it, so it's a closed circle. And the second 2 doesn't have a line underneath it, so it's an open circle. These are your important points where they kind of divide the sections up, and the rest of them are always closed circles. You're going to use this little coding system to help you figure out if it should be an open or closed circle on your piecewise graph. Oh, I have to fill in my -4 and so on. When x is a -4, which is up here, you're going to get a +8, a +6, and a +4. Now you're going to go here for the middle one, and it's going to be a +4, a +1, and a +4. Remember, f of x equals y, so y equals a -3 on all 3 of these. So at a -4 and a +8, 1, 2, 3, 4, 5, 6, 7, 8, it's a closed circle. -3 and 6, it's a closed circle. -2 and 4, it's a closed circle. And it shoots off up there. At a -2, 4, it's an open circle. At 1, 1, it's a closed circle. And at 2, 4, it's a closed circle. And you know what x squared makes. It makes a parabola. And then at 2, -3, it's an open circle, and at 3, -3, it's a closed circle, and at 4, -3, it's a closed circle, and it goes in that direction like that. And here, you'll learn that a closed circle covers up the open circle, and it just makes it a closed circle. So that's called a piecewise graph. So, for the assignment, I changed it a little bit. What I am going to have you do is on 3.5, follow this 1 through 15 odds. (41) A, B, C, and D. And then 47 through 51, which are 3 problems on how to make a piecewise function. So I shortened it up by a lot for 3.5, so keep that in mind.